Welcome to our in-depth exploration of calcium, one of the most essential elements for life on Earth. Today we'll uncover what makes calcium so important not just for our bodies but for the world around us. From its discovery to its everyday uses, calcium is truly a fascinating element. Let's begin by understanding what calcium is and why it's so vital in both nature and science. As we journey through the world of calcium, you'll see how it impacts everything from our bones to the very soil beneath our feet. Calcium was first isolated in 1808 by the English chemist Sir Humphrey Davy. Using electrolysis, Davy separated calcium from a mixture of lime and mercuric oxide. This breakthrough marked a significant milestone in the history of chemistry, as it allowed scientists to study calcium in its pure form for the first time. The discovery of calcium opened doors to understanding its crucial role in both biological and geological processes. Today, we recognize calcium as a building block of life and a key player in many scientific fields. The periodic table, calcium is represented by the symbol Ca and has the atomic number 20. It belongs to the group of alkaline earth metals, which are known for their reactivity and importance in various chemical reactions. Calcium's position in the periodic table helps us understand its properties and how it interacts with other elements. Its unique characteristics make it essential for both living organisms and industrial application. Let's take a closer look at what sets calcium apart from other elements. Calcium is a silvery white soft metal that is relatively light compared to other metals. It has a melting point of about 842 degrees C and a boiling point of 484 degrees C. Calcium is not found in its pure form in nature because it reacts easily with oxygen and water. Instead, it's commonly found in compounds such as limestone, gypsum, and fluoride. These physical properties make calcium both unique and versatile, allowing it to play a variety of roles in nature and industry. Chemically, calcium is highly reactive, especially with water and oxygen. When exposed to air, it quickly forms a dull oxide and nitride coating. In water, calcium reacts to produce calcium hydroxide and hydrogen gas. These reactions are important in many industrial processes, such as the production of cement and the purification of metals. Calcium's chemical behavior also explains why it's rarely found in its pure form in nature, instead existing as part of various minerals. Calcium is the fifth most abundant element in the Earth's crust. It's never found free in nature, but it's present in many minerals including limestone, gypsum, and fluorite. These minerals are essential for the formation of rocks and soils. Calcium also plays a major role in the carbon cycle, helping to regulate the Earth's climate over millions of years. Its widespread presence makes it a cornerstone of both geological and biological systems. Limestone and gypsum are two of the most common calcium-containing minerals. Limestone is primarily made of calcium carbonate, while gypsum is composed of calcium sulfate. These minerals are not only important for building materials but also for soil fertility and water purification. The presence of calcium in rocks and minerals shapes landscapes and supports plant growth, making it a key player in the natural world. Calcium is crucial for all living organisms. In humans and animals, it's best known for its role in building and maintaining strong bones and teeth, but calcium does much more. It's involved in muscle contraction, nerve transmission, and blood clotting. Plants also need calcium for cell wall structure and growth. Without enough calcium, living things would struggle to survive and thrive. About 99% of the calcium in our bodies is stored in our bones and teeth, providing them with strength and structure. The remaining 1% is found in blood, muscles, and other tissues, where it plays a vital role in many physiological processes. Our bodies constantly regulate calcium levels to ensure proper function, drawing from bones when dietary intake is low. This delicate balance is essential for overall health. Calcium is the primary mineral responsible for bone strength and density. Throughout life, our bones undergo a continuous process of remodeling, where old bone is broken down and new bone is formed. Adequate calcium intake is crucial during childhood, adolescence, and older age to prevent bone loss in conditions like osteoporosis. Ensuring enough calcium in the diet supports lifelong bone health and mobility. Muscle contraction relies on calcium ions. When a nerve signals a muscle to contract, calcium is released inside muscle cells, triggering the contraction process. After the contraction, calcium is pumped back out, allowing the muscle to relax. This cycle is essential for every movement we make, from walking to breathing. Without enough calcium, muscles can become weak or cramp easily. Calcium ions play a key role in transmitting signals between nerve cells. When a nerve impulse reaches the end of a neuron, calcium enters the cell and helps release neurotransmitters. These chemicals carry the signal to the next cell, enabling communication throughout the nervous system. Proper calcium levels are vital for clear thinking, memory, and overall brain function. Blood clotting is a complex process that prevents excessive bleeding when we're injured. Calcium is one of the essential factors in this process. It helps activate proteins that form a stable blood clot, sealing wounds and allowing healing to begin. Without enough calcium, the blood's ability to clot is impaired, increasing the risk of dangerous bleeding. Plants need calcium for healthy growth and development. It's a key component of cell walls, helping to maintain structure and stability. Calcium also plays a role in root development and nutrient uptake. Without enough calcium, plants may develop weak stems, poor roots, and other growth problems. Farmers often add calcium to soil to ensure crops thrive. Calcium is found in a variety of foods. Dairy products like milk, cheese, and yogurt are among the richest sources. Leafy green vegetables, nuts, seeds, and certain fish also provide significant amounts of calcium. For those who can't consume dairy, fortified foods and supplements are available. Eating a balanced diet with enough calcium is important for maintaining strong bones and overall health. Not all the calcium we eat is absorbed by our bodies. Absorption depends on factors like age, vitamin D levels, and overall health. Vitamin D is especially important as it helps our intestines take in calcium from food. Certain foods and conditions can either enhance or inhibit calcium absorption. Understanding these factors can help us make better dietary choices for bone and overall health. When we don't get enough calcium, our bodies may draw it from our bones, weakening them over time. Calcium deficiency can lead to conditions like osteoporosis, muscle cramps, and abnormal heart rhythms. Children and older adults are especially at risk. Recognizing the signs of deficiency and ensuring adequate intake is key to preventing long-term health problems. While calcium is essential, too much can be harmful. Excessive calcium intake, often from supplements, can lead to kidney stones, constipation, and impaired absorption of other minerals. In rare cases, it may cause serious health issues like kidney failure. It's important to balance calcium intake and consult healthcare professionals when considering supplements. Calcium needs vary by age, gender, and life stage. Children, teenagers, pregnant women, and older adults often require more calcium to support growth and bone maintenance. Health authorities provide guidelines for daily intake to help people meet their needs. Following these recommendations supports strong bones and overall well-being throughout life. Calcium has many uses beyond nutrition. In industry, it's used to make cement, plaster, and glass. Calcium compounds help remove impurities from metals and are essential in the production of steel. Its chemical properties make it valuable in a wide range of manufacturing processes, contributing to modern infrastructure and technology. Calcium compounds, especially calcium carbonate and calcium sulfate, are key ingredients in construction materials. They're used to make cement, concrete, and drywall, providing strength and durability to buildings. The widespread use of calcium-based materials has shaped modern architecture and urban development. Farmers use calcium compounds to improve soil quality and crop yields. Lime, made from calcium carbonate, neutralizes acidic soils and provides essential nutrients for plants. Calcium also helps prevent plant diseases and supports healthy root development. Its use in agriculture is vital for food production and environmental sustainability. Calcium compounds are used to treat drinking water and wastewater. They help remove impurities, soften hard water, and neutralize acidity. This makes water safer and more pleasant to use. Water treatment plants rely on calcium to maintain clean and healthy water supplies for communities. Calcium compounds are used in various medical treatments. Calcium supplements help prevent and treat deficiencies, while calcium salts are used in medications for heart conditions and as antacids. Calcium-based materials are also used in dental and bone repair. Its medical applications highlight its importance beyond nutrition. Many everyday products contain calcium compounds. Toothpaste, baking powder, and even some plastics rely on calcium for their effectiveness. Its versatility makes it a common ingredient in household items, food additives, and cleaning agents. Next time you brush your teeth or bake a cake, remember the role calcium plays. Calcium plays a role in environmental processes such as neutralizing acid rain and supporting aquatic life. Its presence in soil and water helps maintain ecological balance. However, excessive use of calcium compounds can lead to environmental challenges such as water hardness and soil imbalance. Responsible management is key to sustainability. Calcium is used in the production of electronics and batteries. Its compounds help improve the performance and longevity of devices. As technology advances, new uses for calcium continue to emerge, highlighting its importance in innovation and modern life. Calcium forms a variety of compounds, each with unique properties and uses. Calcium carbonate, calcium sulfate, and calcium chloride are among the most common. These compounds are essential in construction, agriculture, medicine, and industry. Understanding their differences helps us appreciate calcium's versatility. Calcium carbonate is widely used in construction as a building material and in the production of lime. It's also found in antacids, toothpaste, and as a food additive. Its ability to neutralize acids makes it valuable in many industries, from agriculture to environmental protection. Calcium sulfate is best known as the main component of plaster and drywall. It's also used in food processing and as a soil conditioner. Its ability to form hard, durable materials makes it essential in construction and manufacturing. Calcium chloride is used for de-icing roads, controlling dust, and as a drying agent. It's also added to foods to maintain texture and stability. Its ability to absorb moisture makes it useful in many industrial and household applications. Calcium plays a significant role in the global carbon cycle. It helps form calcium carbonate, which locks away carbon dioxide in rocks and oceans. This process regulates atmospheric CO2 levels and influences climate over geological time scales. Calcium's role in the carbon cycle is crucial for maintaining Earth's climate balance. Marine organisms like corals, mollusks, and some plankton use calcium to build shells and skeletons. These structures are made of calcium carbonate and provide protection and support. The health of marine ecosystems depends on the availability of calcium in seawater. Calcium is essential for healthy soils. It improves soil structure, promotes root growth, and helps plants absorb other nutrients. Farmers often add lime to fields to maintain optimal calcium levels and boost crop production. Healthy soils rich in calcium support sustainable agriculture. Calcium is a major contributor to water hardness. Hard water contains high levels of dissolved calcium and magnesium. While not harmful to health, hard water can cause scaling in pipes and appliances. Water softening systems are used to reduce calcium levels and prevent buildup. The availability of calcium-rich foods has influenced human evolution. Strong bones and teeth allowed early humans to adapt to diverse environments and diets. The development of dairy farming provided a reliable calcium source, shaping cultures and populations over time. Calcium compounds have been used in art for centuries. Plaster made from calcium sulfate is a key material in sculpture and fresco painting. Calcium-based pigments have colored artworks throughout history. Its presence in art highlights the element's cultural significance. Animals need calcium for strong bones, teeth, and eggshells. Calcium deficiency in animals can lead to weak bones, poor growth, and reproductive problems. Farmers and pet owners ensure animals get enough calcium through diet and supplements, supporting their health and productivity. As we age, our bodies become less efficient at absorbing calcium. This increases the risk of bone loss and fractures. Older adults need to pay special attention to calcium intake along with vitamin D to maintain bone strength and independence. Calcium supplements are available for those who can't meet their needs through diet alone. They come in various forms such as calcium carbonate and calcium citrate. It's important to choose the right type and dosage as excessive supplementation can cause health issues. Consulting a healthcare provider ensures safe and effective use. Vitamin D is essential for calcium absorption. Without enough vitamin D, our bodies can't effectively use the calcium we consume. Sunlight exposure and certain foods provide vitamin D, supporting bone health and overall well-being. The partnership between calcium and vitamin D is vital for a healthy life. Calcium plays a role in maintaining a healthy heartbeat. It helps regulate the contraction and relaxation of heart muscles. Both deficiency and excess can affect heart function, so maintaining balanced levels is important for cardiovascular health. Hormones like parathyroid hormone and calcitonin help regulate calcium levels in the body. These hormones ensure that calcium is available where it's needed, maintaining balance in bones, blood, and tissues. Hormonal regulation is key to healthy calcium metabolism. Scientists continue to study calcium's roles in health, industry, and the environment. New discoveries may lead to improved treatments for diseases, more sustainable industrial processes, and better understanding of Earth systems. The future of calcium research is bright and full of possibilities. In summary, calcium is an extraordinary element with countless roles in our lives. From building strong bones to supporting industry and the environment, its importance cannot be overstated. By understanding calcium's properties, uses, and impact, we can make informed choices for our health and the world around us. Thank you for joining this journey through the world of calcium.